Teams at airports, cities, and entire countries are leveraging data to enhance safety, break down silos, and solve complex problems. See groundbreaking work in digital twins, reality capture, photogrammetry, 3D scanning, remote sensing, and building modeling. From the stadium of the future, where technology is redefining asset management, to capturing the mysteries of Alcatraz, GeoWeek explores how advanced tools are being applied to the world's most interesting projects. Experience cutting-edge tech, AI, advanced laser scanning, neural radiance fields, and more, and unlock new frontiers in 3D visualization. From the challenges of workforce development to National Spatial Reference System updates, experts reveal what technologies will make the future possible. Take advantage of this time at GeoWeek to dive deeper with experts, explore emerging technologies, have crucial business discussions, and network all in one place. Let's build the future together.
Good afternoon. Good morning, everybody. My name is Adon Banda, and I am very excited and deeply honored, and I can speak on behalf of myself and my colleagues, how excited we are, how honored we are to be speaking at GeoWeek. We are very excited to do a high-level overview of a lot of different projects, so be prepared for a lot of different things that we'll be chatting about, both terminal and landside operations at DFW Airport. So to get started, we've got a lot going on at DFW Airport. As you can see at the top there, we are a city, essentially. We have a zip code, we have fire, DPS, everything you can think of. And we tout the fact that we are the size of Manhattan, and that's all land area that is within the airport property. We're third in the world in operations, we're third in the world for passengers. I think we're closing in very, very closely on Hartsfield-Jackson in Georgia, so we're coming for them. So we have a huge growth challenge at the airport. We have unprecedented growth that's happening right now with the modernization of existing airports and with the growing demand for seamless travel. We're having to keep up, and we're having to pace ourselves in order to keep up with that congestion, with those expectations that passengers have for us. Whenever you travel to an airport, I'm sure you're always wondering, what is my experience going to be like? How is it going to be better than last time? And so that's why we're leveraging AI. We're utilizing GIS, BIM modeling, anything you can think of to be able to meet that challenge. So as you can see here, we have this dynamic model, and this model is pretty comprehensive. It's one of my favorite things that we have within our system, and it allows us to see every phase and every facet of our growth. What's changing, what's evolving, what's being demolished, what's being constructed. We have a new terminal that's being built. These are capital projects that are being built and being planned, and it takes time. It takes effort, it takes coordination. And you can see that, with the building of Terminal F in that red section up on the top left, we're gonna have a lot more growth than we've seen in the past. I think we've grown 20% in the past year, and 20% from the year before that. And so it's really adding up, and it's really, in other airports it may be causing strain, but for us, we are on the forefront of being able to anticipate that. And as you can see, we have a lot of projects happening from now until 2028, and more to be planned. So, as I mentioned, there's 20% growth happening exponentially every year, and we have a lot to prepare for. We have the World Cup that's coming in a couple years, and with coordination from local municipalities, from the county, from the cities, we have a lot to prepare for as far as passenger capacity, as far as how we're planning to receive all of those people, that incoming traffic. With Terminal F, as you can see here, we're adding 17 more gates. We're adding a lot more for customers to be able to see, to be able to pass through. And how do we cope with that infrastructure right now? And so that's what we'll go into. And my colleagues will also mention that as well as they go through their high-level project updates. So one of those expansion projects that we're doing is Terminal C. This is one of our oldest terminals, if not the oldest terminal, and we have a lot of different facets of that terminal that are just kind of degrading over time, utilities, just general infrastructure. And so we're trying to modernize all of our terminals in this manner. Updated signage, updated general customer experience. So what does all of this mean for DFW? We utilize GIS, we utilize BIM, we utilize 3D visualization. All three of those facets married together allow us to plan better, allow us to anticipate and to coordinate just various projects. As you can see, this is actually how we build buildings off-site. It's a big logistical nightmare to try to build everything on-site, on the air side. A lot of security issues, things like that, and so we build it in sections off-site, and then we shuttle all of those pieces one by one in, and it's really cool. I always thought it was pretty awesome. I actually didn't realize before I started with the airport that we actually did that. Apologies. So with that, GIS, BIM, and 3D visualization, it allows us to see that. It allows us to plan for that type of building model. Now, move on. So one of the items that we use at the airport is Biolytics. They are a company that has allowed us to essentially crowdsource our data. And I'll talk to that on my next slide. But we use AI and vehicle cameras to map out our roadways around the airport. Roadways are a huge one. We use this also for runways, for taxiways, not just public-facing roadways. And essentially, it allows us to be more responsive, more proactive in our maintenance of our roadways. When we have a section of road that's doesn't function to its full capacity, we have issues, passengers getting to the terminals, we have people trying to leave the airport, just not unable to do so. And so this product here gives us a score of what that roadway condition looks like and what we should be looking out for in the near future. So a little bit more on that. So like I said, it's more or less a crowdsourcing effort. Very low cost, little to no labor. The type of hardware that we use, we pretty much already pay for because it's with our cell phones or a GoPro of some kind that we mount to our dashboards, we mount to the front of our vehicles, whatever we want. It's very simple. It mitigates downtime, it mitigates post-processing time because it's all uploaded to the cloud. No need for expensive equipment, except for those cell phones I told you about. It allows us to passively collect that data. And it's helped our road crews exponentially. So runways are, along that line, runways are a huge are the lifeblood to our airport. It's what brings traffic in, it's what brings traffic out. It allows us to have the more runways we have, the more passengers are able to come in, and there's implications globally for cargo, for connectivity, so on and so forth. And as you can see here, this is a good time lapse of one of our runways that we just finished up this past year, and we built it in about a year, which to us was pretty impressive, and we were super excited to be able to be done with that project because it was. Obviously we had one runway down for quite a bit. And one of the other capital projects that we're doing, because runways are so essential, is we're going to be building an 8th runway, which is super exciting. And so there's a lot more growth, not just with buildings, but with runways and other infrastructure pieces. So along the lines of runways, so maintaining our runways is very essential. When we have a runway down, there's very serious implications as to, whether a plane can land. So there's scheduling issues that happen when runways are down. We use technology to be able to detect debris. So we use FOD, it's FOD, F-O-D, and it helps us to prevent hazards like debris, animals, and yes, we do have Texas wild hogs that come on the property every so often, so we've got to watch out for those. Bird strikes, things like that. And so all that debris, all that matter is on the airport, and we have to be able to clean that up immediately so that we can have that steady traffic flow of planes and things of that sort. So I was talking a little bit about traffic and things that affect from terminal to gate, from plaza to gate, things like that, of customers getting to their gate. We have this project called Aware, and it's a piece of software that allows us to have a predictive model for traffic flow. It stands for Advanced Warning and Response Exchange. So what it does, it allows us to provide plaza to runway awareness with some key features. And I'll go into some of the data that we actually feed into this. A lot of it relies on AI, a lot of it relies on real-time data. It's paramount that we have that real-time data to be able to predict what's going to happen, what type of traffic incidents will happen. It's our early warning system. It allows us to respond quicker. It allows us to anticipate holiday traffic, for example. Thanksgiving, and the holidays in December. It allows us to anticipate those traffic flows and mitigate any stoppages. One other thing to note too is that all of our signage that we have around the airport will coordinate with this model. We'll be able to update our signage accordingly as we know more and more of a potential traffic incident that typically happens in a certain area of roadway or at a specific point in the terminal, so on and so forth. So some of our current challenges and why we wanted to build something like this is we react to things too late. We get notified of these issues after the fact. And we want to mitigate that because with an airport, we want people to have the best customer experience they can. And if they're stuck in traffic trying to get to a terminal, we want to have them not have to do that. Also, a lot of the times with a lot of airports this size, we have very fragmented data. We have data here, there, silos, if you will. I'm sure a lot of you deal with that in some regard in some of your organizations. It's just overwhelming to process. So we wanted to put all of that into one section, into one piece of software. And we wanted to know our congestion points, and because right now they weren't connected to, the people over here in our DPS department weren't informed over here, and it was just a kind of a mess sometimes. And so we wanted to mitigate that, and so far we have a pretty good response. So I talked about some of the data sources that we'll be using. So we have a phase 1 and a phase 2. Phase 1 is I would say the most important. It's what feeds into this model. The phase 2 data is just what supplements the phase 1 data. So we've got flight data, toll booths, traffic data, incident data, construction, past and present, and I think we want to add future as well. Parking garages, we have sensors for all of a few of our terminals and some of our spaces, parking spaces that is. Weather incidents, weather incidents, FAA incidents, so on and so forth. For TSA gates, LiDAR, cameras, we want to utilize all of that so that way we can detect where that congestion is in real time. So the impact, overarching, we are a large airport that, like I said, that receives a lot of traffic. Both strictly airside, people coming from local, from our area, DFW, and just around Texas, Oklahoma. And we want those people to have increased satisfaction as they come to our airport. All the improvements that we want are focused on the customer experience. We want to boost concession sales. We want to be able to give, I think there's an estimated $8 to $16 million impact on just some of these new terminal operational projects. And in the long run, it allows for more efficiency. It allows for more sustainability and safety. We're not having to worry about those congestion points, and since we have mitigated them, we don't have to. We can make sure that customers get from the plazas, the toll plazas, to their gate safely. So some key takeaways just from my section of my presentation here is growth requires planning. I'm sure a lot of you know that. Growth requires a lot of coordination between departments and eliminating silos. We want to stay ahead of the curve by just ensuring that we're talking to each other, that we're utilizing these technologies to go forward. Number two is viable solutions with real world use. We're not just creating these just to create something cool, just to create something new. Like we're making sure that our end users internally, myself and my colleagues and all of our teams, that we're actually going to use this, and that our upper management also uses these tools to make decisions and to allocate our resources properly. So just make sure you know your use cases. When you do these things, make sure you have that end user in mind. Also, data quality is critical for AI. Your models and your apps and everything that you build are nothing without your data. Nothing without good data. If you're just kind of scrounging things up just to get something built, you may need to reassess a little bit. And I think we had some growing pains with that as well. But as we've gone forward, our data quality has gotten better and better. And now we have standards. Now we have very high standards that we use for these models, and now we can draw that data into other applications. And that's all for me. Thank you very much.
Good afternoon, everyone. Thank you for attending. My name is Kelly Watt. I'm a program manager at DFW. I've been a consultant for the last 3 years working on some very large projects. I manage our digital twin project, our rollout of LiDAR. It's not the terrestrial and SLAM we're talking about, the actually fixed LiDAR. And we'll talk a little bit about that and how it supplements the AWARE project. And today I'm actually going to talk about our water project. As we mentioned, DFW is a very large airport. It's a city, and it's a very complex ecosystem. We have hundreds of buildings, not just our terminals. We're the size of Manhattan. We have about 200 miles of subsurface utilities and pressurized water systems that we need to maintain. And with the amount of construction and change going on, it's really hard to navigate all that. So you see that Don sent, put all that project mapping that we can see for 3-5 years out. It really helps us to coordinate those activities. And we have a real need to get data quickly and in the format that we want it so it can be actionable. And that's really important. We're spending a lot of time kind of figuring that out. So one thing I press on anyone here, the digital transformation is a journey. It goes in steps. And you really need to be taking a step back before you start. Coming to conferences here, you're going to see a lot of cool tools, a lot of things that you want to implement. But if you don't have a strategy and a plan, it can lead to failure. We recently, I work on a working group with the Digital Twin Consortium, and we published use cases for airports, and you can check it out on their website. And this maturity model's listed within that paper. And the foundations here, the systems and systems thinking is really critical. If our systems can't talk to each other, we're never going to get to automation. So the commonality of building data with schemas and and data's also looking at things a little differently. It's not just our BIM models or our geospatial data. It's our IoT data. It's financial data. So it's a lot of things what Adam was showing on all the different data sources we want to bring in that AWARE project to be predictive. So we really need to know where we are before we can chart the journey of where we want to go. That's the main point. Also, having some fundamentals and frameworks in mind when you start to build on some of these major projects. Open architecture is really important for us. Putting widgets in place that don't talk to other widgets really makes it complicated to scale. So really, to truly scale something as large as DFW, we really need to start thinking of an architecture that's going to be able to grow with us. And understand too that our infrastructure is at different life cycles. We have terminals that are 20 years old and we have brand new terminals coming on board. So kind of strategically thinking, well, when can we start leveraging certain data and when we should just maybe put it off until there's another capital project. So really got to think through a lot of those things. And the other thing that's often overlooked is operational. How are our stakeholders going to use this information, these interfaces? We're going to ask people to use different tools. Are they prepared to use those tools? Are our contracts in place? So, even with our service providers, they have different KPIs today, then the KPIs will be in place for tomorrow. So starting to think about what that looks like before the project's over, and you just expect people to use the tools that we put together. So we go through a pretty rigid master planning process, and out of that we can prioritize our use cases effectively and understand the dependencies that are going to be that need to be met. We don't want to get into projects that have surprises, right? And that has happened in the past, and sometimes it's unavoidable, but we do our best to be able to kind of mitigate that up front while we budget the projects and roll them out. And then we got to go out and we have to collect data. So using the appropriate tools, this is a mobile BLK to go. It's low cost. I don't need a lot of accuracy. I'm using this imagery to see sight lines and where we're going to place sensors. So using the right tool for the job is really, really critical, and make sure I have adequate coverage. And the nice thing about visualization, it allows you to see things beyond just the 2D architectural drawings, so that we can make good judgments and decisions to make sure we get it right the first time. So we're going to put a bunch of sensors along the ridgeline of this building so that we can improve our security measures. But this is a 20-minute scan. Data was available within an hour afterwards, and it was appropriate because I didn't need a surveyor to actually collect the data. And we're starting to do LiDAR here at the airport in different divisions. We have our design construction, they have the survey division. We have our control analytics, they have their own equipment as well. GIS is buying, equipment beyond the typical survey 1, 2, 3 and certain georeferencing of data. We're actually having to use scanning. So really, it's broad right across the airport now. It's not just within a single department. We have different needs to be able to use this kind of data. So one of the big projects I'm working on right now is the implementation of fixed LiDAR for scanning traffic and people movement in real time. And we build an event architecture that can inform based on congestion, based on vehicle dwell times. We have people that do very crazy things at our airport. They leave their vehicle, they go in the terminal, and actually when I was out there doing some use cases, a woman left 3 kids in their vehicle and went in the terminal. So these kind of things are always happening, and we need to be able to respond to them quickly and address those issues so that we keep our passengers safe, we keep the congestion moving, and at the end of the day, we're a business. And we can't lose sight of that, right? The airport makes money on landing the aircrafts, bringing them to the bridges and moving people through the airport and making sure that we can capitalize on revenue opportunities at the airport. So if there are chokes, it impacts us financially, and it also impacts us from a reputation perspective. Our cost per enplanement is a factor that we're really conscious of, because it means that American Airlines is going to be willing to put in $3 billion to a terminal because they trust the operation is going to support the capacity. So with this project, we'll be putting basically hundreds of sensors, very much like a video camera, but we use LiDAR technology. We use that because it's more accurate, especially for counting and certain types of identification. But we'll use camera technology as well. Again, with the open architecture, we don't want to just rip and replace one technology. We want to be able to use what we have. And over 5,000 cameras in the airport, so when we use those for what they're best at doing and augment LiDAR for where they kind of fail. And at the end of the day, we have to deliver that service. Again, it could be from a business perspective. If passengers, I don't know if you guys have run to a gate, I don't know how many cheeseburgers and beers you have when you're in a rush, you don't actually get that opportunity to spend money in the airport. So that's a huge revenue impact. Some of the forecasts we're looking about $8 to $16 million in the disruptions alone. So if we can create a seamless experience, we'll be able to have a revenue impact. The picture on the right is actually our Terminal C, which we have ongoing construction. We had an event which we had full gridlock. People were actually getting out of the vehicles and walking. So these kind of events can happen, but if we're ahead of the curve, we can notify resources more effectively, respond quickly, and hopefully don't get into trouble like that. This is a base visualization for our Terminal E LiDAR placement. So it's just a basic model, but what we'll be able to do here is place the LiDAR sensors and show the overlap. So from a design planning perspective, we know we have continuous tracking straight through. We're not going to have gaps. And this is matching to our requirements on the fidelity and accuracy to support the use cases. Because if we don't think through that and we implement and we don't have enough coverage, then that also hardens our ability to meet the use case needs. So, and at the end of the day, where are we surfacing this data? So we have curbside teams, our Department of Public Safety, police have to be notified. So understanding how that data needs to be normalized, contextualized, and delivered to an interface that our stakeholders are using. And that could be in our IOC, which is our Integrated Operational Command on the left there, where we have various stakeholders working in real-time events, or it could be on the curbside, as you can see the photograph on the right. And we need to empower our stakeholders to make good decisions based on good data. So the geospatial part is really important. We need to be able to understand where, when, and the impacts of something happening at a particular point in time. But feeding data, that makes it so much more valuable and rich. So I'm going to talk a little bit about our potable water system and what we've been doing to bring in a bunch of different siloed data and build something a bit more predictive. And I hate to say the word predictive in water because it really is a reactive space. It's not really a predictive, it's more proactive. So the first thing is we need to know where the paper is, because paper is evil. If we can remove paper and we can digitize and be more efficient, these are actual photographs that are taken at cubicles. On the right hand, you see paper work orders that are printed and notes are taken. On the left, you have our Terminal D with all our ballot layouts. So digitizing all this information so we can share it seamlessly and we can search and find information really quickly is important. We also want to surface the data that we've already invested in. Our GIS department is very mature. We've got about 6 analysts under you, plus we have embedded analysts that work within our asset management group. So there's a full-time person just on the water and one on our utilities. That's all their job is, 40 hours a week, is to maintain the accuracy and currency of that database. So what data do we have? What can we surface? And the nice thing about the GIS is it is so flexible to bring into almost any platform. So it's one of the first places we want to look to see what data is available. So in the smart water strategy, we first wanted to import the attributes that we have, which is all our piping infrastructure. We wanted to connect to different business systems, including our Hexagon work order system. So we could trigger work orders when we see things happen. We also want to surface all of the condition assessments that are done. There's a lot of, again, that paper, the PDFs that are in emails. How can we take that information, geospatially laid out, make those layers available, overlay them, so we get more context of what might be happening, right? We have a number of assessments done by a company called Xylem. We're running probes just like in the oil and gas industry. We run probes through the pipe to do condition assessments and also for leak detection. But all those points of interest can be documented and they may not be a problem today, but they can certainly be a problem in the future. We want to know about it. And then we wanted to integrate with our real-time data, which includes our SCADA system, all the sensors that we have in our pump rooms, but we really realized we don't really have a lot of sensors on the system. It's over 50 years old. So we had to go out and do a lot of sensorization. So bringing in high quality pressure and flow, and to build a grid where we're building districts. So it's a very common thing in the municipality world is to be able to grid out your system, understand flow coming in, flow going out, but also consumption. Consumption side is a bit tricky because our billing softwares are not really meant to be real time. We need need to know what you're consuming once a day. So the system was only going to be able to deliver data once every 6 hours, and that wasn't adequate. So we were able to retool the existing infrastructure with an ethermeter to get flow readings every minute. So that's really tremendous. So adding new sensors and leveraging existing sensors to be able to get a lot more kind of proactive. We then take the data, the historical data, we can build models so we understand what the consumption should be, under ideal conditions, and when we have anomalies, and we'll be able to build alerts for anomalies. So the intelligence layers are then built into that. So, historically, how do we do this? Historically, if you're in the water business, it's an acoustics exercise, right? You have to follow the pipe with the listening stick to be able to hear anomalies from the sound perspective. That has become a bit more digital, and we're now using GPR. So satellite GPR can actually penetrate down 10 feet deep and can give us indications of chlorine in the water, in the ground surface. So the red pockets are where we have chlorine, which are indicative of leaks. So now macro level scan, I can get an idea of 10% of the areas that we should kind of focus in on. So that's been really nice and useful there. But we're not going to scan it every day, so it's done once or twice a year. But it is very helpful to kind of identify those leaks where they are. Another project I'm working on is to be able to roboticize what is a very manual process of being able to walk that 200 miles of pipe and to put a ground listening stick to it. So if we can roboticize and have this autonomous, we could have a few miles a day or maybe a little bit more scanned every day. Payload is sent up, machine learning model written over the data that's collected, and we have a GPS map that can tell us where we see our problems. So this is an active project right now. Some of the areas we're going to have to improve is building in RTKs so we get accuracy. We want to make sure we're having good information for the subsurface documentation, that we're actually walking on top of the pipe. And we need to be able to work in versatile conditions, right? Because it gets very hot, and we want to make sure that we can have the equipment support those physical environments. And again, moving to more of an event-driven architecture. The way we usually see leaks, you see your SCADA system, something very anomalistic, but usually there's water coming out of the ground. So hopefully we can get to a point where leaks, especially when they don't surface, we'll be able to understand where a potential leak is and get ahead of it, especially when we have runways and terminals where cavitation of water could be catastrophic. So these are the types of assessments that we're doing, and producing reports, and again, taking those reports and be able to surface it onto a GIS layer, and then also relate it to both our IoT data and our work order history data, so it really kind of brings everything together so we can see a clear picture of what's going on. So the districts we built, this is how it's mapped out. So we have 6 districts, and then we have sub-districts between those. On the right-hand side, you'll see our micrometer flow meter. So it's a highly accurate bidirectional flow meter. So we have about 22 of these going in, I think about 35 pressure sensors. And then we're going to be upgrading our billing software, our billing flow meters to real time as well as part of this project. And you can see that the leaks are expensive. These 2 leaks alone that I mentioned, one was $5.7 million. It caused disruption on the airfield as well, which is far more impactful than when you have a runway go down. That's our primary generator of revenue, so that's a big deal. And the temporary leak that we spent $1 million on, that was a year ago, broke again. So that's actually turned into like a $3 or $4 million repair. So kind of getting ahead of curve. There's a lot of stress putting on these systems, so if we can maintain them more effectively, hopefully we won't have these types of issues that come into place. So this is our GIS layer within our digital twin, where we've surfaced all these different layers of data in the same location, real-time data, work orders can be created, and we're really building a 3D dashboard as the next phase to this, but for now, this is quick and easy to be able to bring those layers together. Adon's team's been great moving to the cloud to be able to surface this data in an interface that would be helpful for us in the digital twin that we're using. And then again, to be able to bring that data into our operational interfaces. So our bridge manager at IOC can say, yes, there's a leak and it's going to impact these people, and we can notify. and we can get ahead of that. So those are really critical things that we're considering. So the takeaways I'm going to leave you with today, before you implement really cool technology, have a plan and a strategy, and that plan and strategy is also inclusive of defining the data that you need for the project, the business systems that you're going to need to communicate between, and don't forget the stakeholders. That's really important. It usually becomes a last thought, and it really needs to be a first thought. How are people going to use the data? And we need to be able to scale, right? So the size and capacity, doing a POC is great, but how are you going to bring that to the next level? How are you going to scale it straight across the airport? And bringing together proper schemas and common information models, systems and systems thinking really will help to empower you to be able to have that kind of scalability. So those are my takeaways. Thank you for your time, and we will be speaking again at 4 o'clock, and I'm going to dive really deep into our digital twin itself and some of the use cases, so we'll hopefully see you some of there.
Wow, thank you, Kelly. Exciting times in DFW, isn't it? And a great audience to share this journey. So, digital transformation in DFW, it starts with business and not technology. I'm going to show you 3 customized solutions. There are many. I chose 3 of them. So first, I will show you digital twin and how we are keeping it updated, how we are doing the change management. And then I will show you how we are supporting our Department of Public Safety in pre-incident planning and post-incident planning. And then how we are empowering our environmental teams to take data-driven decisions. So digital transformation, as I said, it starts with business. It's very important that we collaborate with our teams and departments and look for what are the internal business processes that need to be digitized. So it requires understanding their pain points, understanding what their objectives are, and then developing a solution where these stakeholders and these teams are part of the solution. So by the time we hand over those solutions to our teams, they are the owner of the solution. Because at every step, we need to make them part of it. So this is one of the examples how we are going through the journey of this digital transformation. In digital twin, I was listening to one of the presentations by Eric. Sorry if I mispronounced the name. He showed there are multiple aspects of digital twin. There are so many layers about it. And Kelly talked about open architecture and interoperability. It is so important because in digital twin platform, there are you get data from multiple sources. So it's so important that it is, everything can be integrated into one platform. Anyways, in digital twin, it is accessible to one and all in DFW. It is accessible to leadership, it is accessible to all technicians who are working with the assets on day-to-day basis. And it's a live platform, which means that if any asset is changed, if any asset is maintained, the technician, they know, okay, this asset has changed and it has to be reported. We make that process automated. Earlier it was more meeting based and all those, but now it is automated. They can report it that this asset has been changed, this name is changed, or if there is an improvement in infrastructure. So that BIM model will also change, right? So that everything, it can be reported and can be changed. Also, to bring out the change in the platform, there are multiple teams involved in it because there are so many aspects to digital twin. There is one team that handles the BIM model, another one is building automation system, or there can be a minor thing that the asset name is changed. Asset is same, but just the name is changed. So all these things had to be updated in the platform, and there are multiple teams who carry out this task. So this need to be, earlier this used to be a lot of calls, lot of meetings, but now we are automating this process. So now there is automatically a team will be informed that this form regarding the BIM is submitted, you need to update the BIM model. And they will be notified and improve the BIM model or update the BIM model, and then there will be a quality check, and then all the stakeholders will be informed that digital twin platform is updated and this update was done, and here is the link. Another example I will give you is passenger boarding bridge. Passenger boarding bridge or jet bridge or PBBs, it has multiple names. Let's call it PBBs. So passenger boarding bridge or PBBs, we have 177 gates. It means we have 177 PBBs. And 2 hours before a flight land, these PBBs has to be ready. So you can imagine that all the time, every day, these PBBs are getting inspected. So I will not go into the process, what used to be the process and how it used to be inspected and all, but now we have again automated that process. And in a PBB also there are multiple sections. There is wheel bogie, there is GPUs, there is a ground processing unit and other mechanical part, wheel bogie, cab, tunnel, whatnot. So we have made a process, and it is divided into 12 sections. And whenever a quality inspector, they submit a form, the supervisor or the team, they will be informed that these many forms have been submitted and there was the issue and a problem has submitted about the bridge exterior. And there are multiple questions inside every section. These all questions are yes or no type questions. If quality personnel type yes, it means everything is good, everything is functioning right. But if it is no, then they upload an image or a video. It is so important for PBB inspections that we have structural and non-structural data both. Why? Because when we add images or videos, it can directly be sent to the vendor, and vendor can see that what kind of technical expertise is required, what tools are required, and whether it requires any technical person to be sent or not. It can be resolved remotely. Other than that, automating this system, we can also see that what all gates are more frequently having a problem in a particular area. We have more analytics about it. And we can foresee, we can plan our next inspection or long-term repairs about a particular PBB at any particular gate. So ultimate customer experience is the goal for DFW. Earlier, during my orientation also, we were told that when a person starts their journey from their home or their hotel, they become our customer. But guess what? It's not. It's actually started much before. We all like to plan our travel. We all like to know how long it will take me to go to the airport, how long it's going to take me for the security check or bag check-in. All this process is automated. It's there in the DFW app. And we also have all the road closure and construction. So DFW, we have throughout the year we have road maintenance and road construction going on. Sometimes it is only in the day, sometimes in night, sometimes in a few hours of the day. Everything is updated in the app. Now our next step is that it should be integrated to the navigational app, because many people like to use other popular navigational apps, so it has to be integrated. We are working on it. Other than that, this information is also helpful to our Department of Public Safety. They like to know what are the congestions or roadblocks in DFW area, but they are also interested what are the congestions around the DFW area. Passengers who are coming from outside of our DFW AOR, they would like to know if there are any congestion or they need any kind of assistance, so that we can channelize our team in a particular route to help those customers who are heading towards the airport. So nothing like it if you can catch your flight in adverse condition, right? Also, to our Department of Public Safety, we provide all sort of critical points, field data like where is the electrical shut-off, where is the gas disconnect or fuel pipelines or NOx box or alarm system, whatnot. So these things, they don't change, but still we do the 6 months inspection to check for the quality, and if there is a change in infrastructure, we update it into the map. This also helps them in the post-incident planning. Sorry. Other than these field data, we also have live data. We have, as Kelly mentioned, we have 5,000 cameras all over the airport. Actually, it's more than that, but just in the terminals, we have 5,000 cameras. And there is a live feed from all these cameras, which is available to them in a very simple dashboard with all the GIS layers in it, all the critical data points, and also 360-degree scans of all utility rooms. Just in case if there is any threat or some situation happens, our DPS team, they know if they have to break a wall or something, they know that where is the nice location to break it without damaging it too much. If there is an electrical line or utilities are going on, they know that what is the correct location to handle that. Last but not the least, environmental monitoring or environmental quality is very important for DFW. Indoor environment quality and also outdoor. We have stormwater line throughout the DFW, and we make sure that our creek, our streams, and our lakes, the water quality is good, the aquatic life is in good quality. They are healthy. So how we do it? We have all over the airport, we have the outfalls, and these outfalls are connected to the lakes or streams. We have sensors placed all over the outfalls, and we check for stormwater quality. And if we find any kind of contaminant at that stage, we can always divert our water toward the treatment plant. So this way, we make sure that our environmental team researchers, they can do data-driven decision making. So even though it sounds very straightforward that we start with business and not technology, but it is worth reiterating that digital transformation starts with business and not technology. It starts with trying to understand the real problem, the real objective, and trying to solve it, rather than focusing on the peripherals. And for this, it's important to communicate with the stakeholders, making them part of each and every step so that we can provide them appropriate and good solutions. And of course, not to overcomplicate things and just focusing on the problem and finding a solution for that, and then keep upgrading. And it's a continuous process, it's a never-ending process. So you keep upgrading your system. Thank you, and hold tight. Alan is going to do an announcement, so please stay, and I'm looking forward, we all three are looking forward to see you again at 4 p.m. It will be a deep dive section, and we will be happy to take questions, and it will be more interactive. Thank you.
Greetings all, welcome to Denver. Thank you for a wonderful presentation, team. It's presentations like that, for long-term attendees of this show, whether it was SPAR, whether it was ILMF, or just GeoWeek in recent years, that's the promise of geospatial. It's exciting to see things come together like that. The reason I'm here today, very briefly, on the back of your badge, World LiDAR Day, this Wednesday, February 12th. There's some instructions there that, this is a quick explanation of what's happened. The founding members you see here on the screen came together last year, put together this event, something that will occur annually, similar to, say, GIS Day, National Surveyors Week in March, but something specific to LiDAR. The shows I mentioned a moment ago, SPAR, ILMF, LiDAR underpins all of this. At least it did for us as the media. So last year and this year, the founding members, this is something that we've just got the ball rolling. And if I can say one thing to you today, it's not only to make the most of the show here, but to engage with World LiDAR Day. You might not have something to present just yet this year, but if you could share, if you go to the site, lidarday.com, or just consider sharing the fact that it is LiDAR Day on Wednesday, that would be good. And then next year, maybe, brownie points for those that could perhaps share what it is you do with LiDAR, whether you develop or implement whatever that is. So just again, a word about what World LiDAR Day is. There's a session Wednesday, 2 o'clock in the exhibit hall, a special panel, a deep dive, if you will, from some of the founding members. I'd briefly like to thank Carla for her efforts and for the team at DIVCOM, Wolpert for extra emphasis on this, but that's it. I believe the exhibit hall's open. Enjoy, have a productive week, and happy World LiDAR Day on Wednesday.
Nope, not until we'll do one at a time and then you'll walk up.
Okay.
Yeah. Nice to meet you, by the way. Carla. Okay, you got the clicker? All right, and you've got 1 minute and then you can start. I'm gonna also just briefly tell them what session they're in, okay. That would be
Wait, where am I?
just so that everybody knows they're.
This isn't the Home and Garden Show?
Yeah. We really look like a home and garden crowd, do you
Hey,
know?
I don't judge.
All right, you ready to start? Whenever you're ready.
Okay.
They'll switch it to once you get up there.
Okay, sorry, just wanted to test. So cool, it's about 2 o'clock p.m., so I figure we may as well just go ahead and get started with this session. So the